Hello, everybody. Welcome back to the second part of factoring. Now, we are looking at the hard trinomials, and we call these the hard trinomials because the leading coefficient is obviously, hold on a second, there we go, is not equal to 1. So that leading coefficient is not 1. The A value is not 1. When you have an A value that's not equivalent to 1, you have to look at other ways of including that leading coefficient in the factors. So the method we're going to discuss here is the AC method. I put AC method. Now, sometimes you will hear it referred to as factoring by grouping, using factoring by grouping to factor a hard trinomial. There's other methods that people talk about, like splitting the middle term. I can see why they would call it splitting the middle term. So just go ahead and hang on, and I'll show you why they would call it splitting up the middle term, because eventually we're going to have to do that in order to factor these. So the steps, guys, for factoring using the AC method. Number one, we want to make sure we find the product. Find the product of A, the leading coefficient, and C, the constant. Let's go back on this one. I don't need all that, okay? So we're going to find the product of A and C. Number two, you're going to find two factors of AC whose sum, you know, the product, okay, whose sum is B, the middle term. Now, for these guys, once you get to this point, once you figure out those two factors that work, you're going to rewrite the trinomial into a four-term polynomial by splitting, you see that? By splitting the middle term. So that's why they refer to it sometimes as splitting the middle term. Number four, guys, we're going to then factor by grouping. And factoring by grouping was covered in part one of factoring, okay? Factor by grouping. Now, guys, listen, as always, I am going to do a few examples with you guys. This time around, I think I'm going to do 3 examples. And so as we do this, pay careful attention. Of course, my goal is to help you get through this step by step, and you know, allow you an opportunity to practice. I don't like just doing one example, okay? So guys, here's example number 1, 6x squared plus 17x plus 10. So the A value is 6. The C value is 10. So we're going to go to the side, and we're going to multiply the A value, which is 6, by the C value, which is 10. So the product is 60. So we got the product of A and C. Now, the next step is to go ahead and find two factors of the product, in this case 60, that add up to B. What's the B value? 17. So we want to find two numbers that multiply to give us 2 multiply to give us 60. And when we add them up together, we get 17. So think about numbers that multiply to give you 60. You got 10 and 6. When you add them, that's not going to be 17, so that won't work. 3 and 20, when you add them, you don't get 17. That won't work. However, 15 times, oh, wait a minute. 15 and 4 is, let's see here. 15 and 4, guys, multiply to give you 16. 60, but 15 plus 4 doesn't give you 17, okay? So you see, there was a whole bunch of factors there, right? So you have to be really keen with the factoring in order to come up with these factors. 12 and 5, though, 12 times 5 is 60, and yes, 12 plus 5 gives you 17. So there's the factors that work, guys. So now we're going to go back to the polynomial, rewrite the polynomial. And by splitting up the middle term so that it becomes 2 terms. So here, guys, the 17x, we know the 2 factors that work are 12 and 5. So we're going to take the 17x and split it up into 12x plus 5x. So we split up 17x into the sum of 12x and 5x. That's still 17, by the way, okay? And so now we have a 4-term polynomial. And how do we factor a 4-term polynomial? By grouping. So we're going to group the first 2, group the last 2, and factor out the GCF. And this group right here in the first group, the GCF would be 6x. So once we factor it out, that leaves us with x plus 2. While the GCF in the second group is 5. So that leaves us with x plus 2. Now, remember, when you're factoring by grouping, it's a must for these 2 parentheses to be identical. And yes, they are the same. So that becomes a GCF as well. So you want to factor it out. And if you factor it out from here, that leaves you with 6x right there. And if you factor it out from here, that leaves you with 5. So there's your factors, guys. So step-by-step process, AKA the AC method, to lead to the correct answer. Now, guys, math is all about being versatile. It's versatility. You have to make sure you use methods, okay, that will work, that's efficient, that will get you to that answer the fastest, okay? That's what this is about. So, personally, what I like to say is that not one method is the best method to solve all of these, guys, okay? Yes, it depends on the problem. So, guys, here we go. Next one, number 2, the second example. This time I have 12x squared. I've got a minus in there, okay? And then minus 2. So here we're going to multiply 12 times negative 2, and 12 times negative 2 is negative 24. So now we're going to pause and ask the question, what are 2 numbers that multiply to give us negative 24? And when we add them together, we get 5, okay? Now, if it's difficult to maneuver with the negative, you might want to approach the question like this. What 2 numbers multiply to give me 24? And when I subtract them, I get 5. For me, I think it makes more sense to students because they don't have to worry too much about that negative, okay? So what are numbers that multiply to give you 24? Well, 8 and 3 multiply to give you 24. And when you subtract them, do you get 5? Yeah, it does work. It so happens that it works. So now we're going to take the polynomial and we're going to split it up into 8x minus 3x. Now remember, guys, the larger factor gets the sign of the middle term. The middle term is positive, 8 is larger, so it gets the sign of the middle term. So now we have a 4-term polynomial, and so we're going to factor it by grouping. The GCF in the first group is 4x. We're going to factor that out. So that leaves us with 3x plus 2. In the second group, guys, I don't know, you notice that there's a 3x plus 2 in there? I mean, there's a 3x and a 2 in there. The only difference between this parentheses and this one is that the signs are different, okay? There's a negative in there. So you might as well just factor out that negative 1, leaving you with 3x plus 2. So now, guys, you will notice, yes, the 2 parentheses are identical. So you factor out the parentheses, and that leaves you with 4x minus 1. And there's your 2 factors, guys, just like that. And you're done. Yeah, okay. So I think I'm going to do, let me see here. Should I do one more? Yeah, I should do one more. Let me just go ahead and do one more. And again, guys, I think I'm just going to do one with a negative, another negative, okay? So here comes the next one. This is the third example. And on this one right here, I'm going to do 2x squared plus 3x minus 35. I'm doing the negative ones because I know students get really confused with the negatives, okay? So the a value is 2. The c value is negative 35. So I'm going to multiply them. That's a, that's c, okay? Multiply them. I get negative 70. Now, pause and ask the question, what two numbers multiply to give you negative 70? And when you add them together, you get positive 3. If that's not making sense in your head, you can ask this question. What two numbers multiply to give me 70? And then when I subtract them, I get 3. So those two numbers, those two values would be 10 and 7. So now, guys, I am going to take that trinomial and rewrite it as 10x minus 7x minus 35. So once again, I end up with a 4-term polynomial, and the majority of the time when you're factoring a 4-term polynomial, you got to use factoring by grouping to factor it. So guys, I am going to group the first two terms. By the way, that just means you put parentheses around them, and group the last two terms. In the first two terms, you notice there's a GCF of 2x. So you factor that out of those two terms, leaving you with x plus 5. Now, if you go to the second group, obviously, there's a negative 7 as a GCF. So when you factor it out, that leaves you with x plus 5. Once again, guys, you notice the two parentheses, they're identical. So you factor out the parentheses. And when you factor out the parentheses from here, it leaves you with 2x. And when you factor it out from here, it leaves you with 7. And guys, just like that, we're done, okay? So that was the factoring by the AC method, using the AC method to factor. And so the last part of the factoring, guys, is the special types of factoring. And we're only going to really just look at one because there's another one we could look at, but in a way, we've already covered it. So I'm just going to go ahead and look at the differences of squares, guys, okay? Special types. Now, under the special types, we could do the perfect square trinomials, perfect square trinomials, but I'm not going to spend time on the perfect square trinomials. And when we talk about the perfect square trinomials, we're looking at problems like this, guys. X squared, let's say, plus 6x plus 9. When you factor this, okay, you want to find two factors of 9 whose sum is 6. Now, the two numbers that multiply to give you 9, but add up to give you 6 are positive 3 and 3. Now, what you will notice is that you have a repeated factor. And so because you have a repeated factor, you can take this and rewrite it as a binomial squared. So essentially, guys, the perfect square trinomials, the first term is a perfect square. Whoops, the last term is a perfect square. The first term is a perfect square, okay? And so when you take the square root of the first term, the square root of x squared is x. I need a different color for this one. Okay, that one is x. And then when you take the square root of the last term, that's going to give you 3. If you multiply the first term and the last term, these two numbers together, you get 3x. And if you double it, it gives you the middle term. So you can quickly check and see if you actually have a perfect square trinomial. So if you know you have a perfect square trinomial, the quickest way to factor this is to take an x on the x squared and then half of the 6. Take an x on the x squared and then take half of the 6, half of the b term, and then square it, guys. Now, we're going to encounter these again when we talk about factoring, okay, to complete the square with the circles and completing the square to solve quadratic equations. That's a big one, guys. So I'm not going to spend that much time right here with perfect square trinomials because we can catch this later and we already have enough methods to be able to do that, okay? But the ones that I really wanted to focus on, guys, are the difference of squares. Now, for the difference of squares, and again, this is another one you're going to see over and over again. Difference of squares, guys. For the difference of squares, these are some of the easiest problems to factor. The difference of squares look something like this. It's a binomial, guys, and you have a minus sign in the middle. It's a difference, the difference referencing the minus sign. Squares, these are the squares right here. That's a perfect square, that's a perfect square. So if you have a difference of squares, to factor this, guys, into two binomials, okay? You set up your two binomials. A squared, you want to take the square root of a squared, that's going to give you a. You place an a in each parentheses. Because it's a difference, guys, one of the binomials must be a sum, the other one must be a difference, because a positive times a negative always gives you a negative. And then same thing with the b squared, guys. Take the square root of b squared. The square root of b squared is b, and you place a b in each parentheses. But guys, remember, as always, always be on the lookout for a GCF. You should ask that question first. Does this problem have a GCF? So guys, I'm gonna run through some examples right now, and then we'll go ahead and move on. By the way, guys, let me add this in here too. The sum, if it is the sum, remember sum means addition, of two squares, the sum of two squares cannot be factored, so we call it prime. The sum of two squares is prime, guys. It's not factorable. You can only factor a difference, referencing that minus sign in the middle, of two squares, difference of squares, okay? So guys, let's go ahead and practice a little bit. Now, I didn't give you guys any steps, but I'm going to go straight into the examples because I'm watching the time. It's approaching that 30 minutes mark, and I don't want to keep you guys for that long, guys. Just remember, once again, if you have the sum of two squares, you cannot factor that. That's prime, okay? So be careful with this. Now, here are some examples. Number one, I'm going to keep it easy, guys. X squared minus 25. Again, you want to set up your two parentheses. X squared splits up into x times x. And because this is a difference, one of the parentheses will be a sum, one of them will be a difference. Take the square root of that 25. 25 is a perfect square, and that gives you 5. So a 5 goes into each of the parentheses, guys. Yeah, it is very straightforward. So here comes number 2, and I'll try to do about 4 examples with you guys because some of these are a little bit more challenging. So here's the next one, x squared minus 81. Once again, set up your two parentheses. X squared is x times x. One is a sum, one is a difference. Take the square root of 81. Square root of 81 is 9, and you're done. All right, guys. Number 3. This time around, guys, there's a leading coefficient here. The leading coefficient is 64. So you have to be very careful with this one. You still have a sum and a difference for the two binomials, but this time you're actually going to have to take the square root of 64. The square root of 64x squared is going to give you 8x. So 8x goes into each parentheses. And then you take the square root of 9, guys. The square root of 9 is 3. And there's your factors. 8x minus 3. 8x plus 3. By the way, I forgot to mention this, okay? Listen, guys, when you have two binomials that look almost identical except the signs are different, we refer to them as conjugates, okay? They're called conjugates, okay? So you will see this term used over and over again. All right, now I'm gonna do one special case, or maybe I should do 2. Okay, do I have, oh, we got a few seconds left. Okay, so let me do one special case. Now, for this special case right here, guys, look at it. It's x to the 4th minus 64. When you break this up, guys, it's going to break up. The x to the 4th is going to break up into x squared times x squared, because x squared times x squared is x to the 4th. And remember, it's a sum and it's a difference. The square root of 64 is 8. Ah, Shazam. I was going for something else, guys. Shazam. Oh, well, this is it, guys. You leave it like this. You know what? I got to do one more because what I was going for did not get accomplished, guys. So let me go ahead and go and do this one right here. And we'll call this number 6. X to the 4th minus 16. I'm trying to make a point, so this is why I'm doing this one. Again, x to the 4th is x squared times x squared. And then the 16 factors to 4 times 4, negative 4 times positive 4. Now, guys, this is the point I was trying to make. This is a difference of two squares because 4 is a perfect square. This is a sum of two squares. Remember, you cannot factor a sum of two squares, but you can definitely factor a difference of two squares. So which means you can factor the x squared minus 4 further. So guys, I'm going to split it up into negative 2 times positive 2. And there you go. Okay, take that square root of 4, get positive 2. And so the factors would be x minus 2, x plus 2. And guys, just like that, I am done because I only promised about 30 minutes and we're slightly past the 30 minutes. So guys, until next time, bye everybody.